Hello everyone, this is Mr. Molo for lesson 6-5, solving exponential equations. All right, so for this, there's some questions that are going to be super simple. Some of you are going to be like, Mr. Molo, it's exactly what we did in chapter 1, and you're right. So we're solving exponential equations. So that means we're just looking at the exponents here. And if you look at questions 1, 2, and 3, and 4, these are going to be the easier ones of the bunch because the bases are the same. 3 and 3, 8 and 8, 6 and 6, 5 and 5. They all have the same base. So really, we're just looking at the exponent. So our exponents for that one is 4x and 12. And we're going to make them equivalent. We're going to make them the same. So 4 times x equals 12. So going back, we're going to divide each side by 4. So x equals 3. Now they're equivalent. This side says 4x, x is 3. So 4 times 3 is 12. This side says 12. They're equivalent. 3 to the 12th power, 3 to the 12th power. Okay, same thing on number 2. I got x plus 5 equals 20. So I'm going to subtract 5, and I get x equals 15. 15 plus 5 is 20. 8 to the 20th, 8 to the 20th. They're equivalent. Okay, here we run into a little bit more difficult because now we have 2x. So I'm going to subtract 4x from each side. So I get negative 5 equals 2x. Negative 2x, sorry. Divide both sides by negative 2, and we end up with positive 5 over 2 equals x, or 2.5, whatever number you want to use. Okay, and then the last of these easier problems, so 6x minus 3 equals negative 3 plus 4x. So I'm going to get my x's together, subtract 4x, I get 2x minus 3 equals negative 3, add 3, and we figure out that x equals 0. Okay, so these are going to be the easier of the bunch because they have the same bases. And then we get to 5, 6, and 7, and we see that they're different bases, but we couldn't make them. We have to change one of them to make them the same base. So I have 4 raised to the 2x plus 11 power. So I need to make 1,024 into a 4. So if we use our calculator, I would just start off 4 times 4, so 4 squared is 16, times 4 again. Oops, no, not 44. Try that again. So times 4 again is 64, so now we're at 4 to the 3rd power. Times 4 again, 4 to the 4th power, we're at 256. And times 4 again, we're at 1,024. So I know 1,024 is really the same as 4 to the 5th power. And then over here, I didn't have to change anything. I still have 4 raised to the 2x plus 11. So now I'm just going to set, again, my exponents equal to each other and solve for those since they have the same base. So 2x plus 11 equals 5. So subtract 11 from each side and get 2x equals negative 6. Divide by 2, and we figure out that x equals negative 3. Okay, same thing on number 6. I have 8 to the raised to the 3 minus 2x, and it equals 512. So I got to figure out what power is 8 to what power gives us 512. So again, let's go back to our calculator. 8 times 8 is 64. Times 8 again is 512. So it's 8 to the 3rd power gives us 512. So we're going to set the exponents equal to each other. So 3 minus 2x equals 3. Subtract 3 from each side. So I'm left with negative 2x equals 0. Divide by negative 2. So we're left with x equals 0. Okay, last one of these where we have to change it once. And we already kind of did this one on number 5. So I remember that 4 to the 4th power is 256. So now I have 7 minus x equals 4. Subtract 7 from both sides. You have negative x equals negative 3. Now let's divide by negative 1 to get rid of that negative in front of the x. So we end up with x equals 3. Okay, now once we get to 8, now it looks like we're going to have to change both of them to make them both have the same base. Okay, so you got to think, what base can 49 and 343 have? Okay, and the answer is 7. 7 squared is 49. And now, since it already has that x minus 2 up there, it's actually going to go in parentheses, and we're going to have to distribute that in a second. And then 7 to the 3rd is 343. So you're trying to get them both to have the same base. So you couldn't have picked like 7 and like 3 there or something because they wouldn't have had the same base. So 7 can go into 49, 7 can go into 343. And then like I said, you're going to need to distribute here. So that really becomes 2x minus 4 equals 3. We're going to add 4 to both sides. So I end up with 2x equals 7. Divide by 2, divide by 2. X equals 3.5. Okay. Doesn't kind of look like a 3 there. All right, let's look at another one. Like number 10, you kind of have an option here because 9 can go into 81, but 3 can also go into 81. So I'm going to do it both ways to kind of show you. So let's do it first way. And let's use 3. So 3 squared is 9. And then 3 to the 4th power is 81. Okay, so now I'm going to distribute. So I'm going to get 2x minus 8 equals 12x. I'm going to subtract 2x from each side. So I'm left with negative 8 equals 10x. Divide by 10, divide by 10. And I'm left with negative 4/5 equals x. But some of you are probably saying, but Mr. Molo, can we just leave it as a 9? Because 9 times 9 is 81. And you're right, you could have. So I could have 9 raised to the x minus 4. And then 9 squared is also 81. So I'm just going to add that and leave that 9x to the 4th the same. So x to the 4th over here, 6x over here. Subtract x, I get negative 4 equals negative 5x. Divide, divide, and guess what? You're still left with a 4/5 there. Negative 4/5, sorry. Okay, let's do one more like that. So let's do number 11. So let's make these both 8s. So I know 8 squared is 64. And I know 8 to the 3rd is 512. So I'm going to distribute that. So I end up with 2x plus 2 equals 3x. I'm going to subtract 2x from each side, subtract 2x from each side. So I'm left with 2 equals x, and we don't even need to divide there. Okay, so those are as hard as it's going to get when you have to change both of them. Okay, you do have some on this page, and we'll kind of see how it looks. So some of these is, oh, Mr. Molo, like how am I going to get 1/7 x to equal 2041? And so the answer is we're going to have to think about those negatives again. So 7 to what power gives us 2,401? So 7 times 7 is 49, times 7 again, times 7 again. So it's really 7 to the 4th power is 2,401. So that means 7 to the negative 4th power. We would have to flip that. And that would also give us 2,401. So if I have negative 4 times x, that's negative 4x. This is that to the 1st power. So we end up with negative 4, equals x. Okay? And then some of these, it tells you to use a graphing calculator. So kind of a big hint there that some of these might be a little more difficult. I'm going to start with 17 here to kind of show you what it looks like. So I wouldn't use this graphing calculator just because it's going to be so hard to move around. I would use a Desmos graphing calculator. So I'm going to type that in. Instead of doing 1/4, I'm just going to do 0.25. And it's raised to the negative x minus 1 power. Okay, always make sure that you put that exponent in parentheses. And I'm going to put a y equals there too. And then over here I have y equals 18. Okay, now I'm going to use, and this is why I would use this instead of the graphing calculator, because then you're going to have to, it's easier to see here. I'm going to look and see where they cross. And where they're crossing is going to be my answer. And remember, we're trying to solve for x, so we're looking at where x is crossing. So x is crossing at 1.08, and that's going to be my answer, 1.08. We could also use the graphing calculator to find problems like this too. So let me try this one and see if it's even possible. I mean, I know it's possible, but let's see if it's even faster. So I'll show you the 1/7 raised to the x power, and y equals 2,401. So for some of these, it's not even going to be any faster. Some of you are like, Mr. Mola, why wouldn't I just do that all the time? Well, this is why. 2041 is going to be way up here. Hang on. Just keep waiting. Keep waiting. Keep waiting. Keep waiting. Almost there. There it is. And so if I click there, again, the x is -4, just like we figured out on the homework, but for some of them, you're going to be scrolling forever. Like if x is like 5,000 or 10,000, or some of them have x, as 50,000, you're going to be scrolling for a long time to find that. I'd say it's almost probably faster to just do the algebra and actually solve for it instead of plugging it in here, okay? Yes, you could do it that way. Again, I'll show you on the other ones, like, let's go back to that first one, because that first one had like 3 to the 12th power, didn't it? So y equals 3 raised to the 4x, and then y equals 3 raised to the 12th power. That's 531,441. So you're going to be scrolling for a long time to get all the way up to 531,000 just to figure out that answer, especially since we got it on that pretty quickly, was 3. It's where they're crossing. X is crossing at 3. So you could use the calculator for all of them if you really want, but for some of them you're going to be scrolling a long time to figure out that, the answer is something simple like 2. Okay? Let's look at a couple other of these that we're going to put in the calculator. So I would only put them in the calculator if it says use the graphing calculator. Again, you could put them in for all of them, but it might even take you longer to put them in for those. Okay, let's look at 19 down here. So I have 2 raised to the x plus 2 power and 5 raised to the x minus 3 power. Ooh, this one might take us a while to find. Alright, hang on, let me zoom. Oh, yeah, this one is going to take us a while to find. Okay, so this is exactly why I don't like this method, but for these, when they have different bases, you kind of don't have a point. So it looks like they're crossing about right there at 6.778. So that's when they're going to be crossing. So that's going to be my answer. So x equals 6.778. Okay, let's look at some of these other ones that I skipped, and I skipped them on purpose, and you'll see why here in a second. So if we look at number 16, we got y equals 3 raised to the x plus 3 power. And we got y equals -9. You're like, Mr. Mola, why is this going to take forever? Why wouldn't we just put this into the calculator? Well, if we look here, it doesn't look like they're ever going to cross. And that's true. That graph, the black line, is only going up, 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 up. And the red line is just a horizontal line. So some of these are going to be no solution. So maybe a good idea on those graphing ones to plug them into the graph and see if they're ever even going to cross so you can see. So we got one more that's going to be a no solution, so we can kind of see what they look like. So number 18 is also a no solution. So y equals 3 raised to the x power, and y equals -2 raised to the -x. Whoops. -x plus 1 power. Again, green line going up, 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 up. Purple line going down, 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 down. The only chance that they even come close to each other is right there, and you can see that they're never touching. So since they're never touching, they're never crossing, another one that's going to be a no solution. Okay, so again, you can use the calculator for all these, but if you're scrolling, trying to figure out where they touch, it might take you longer. It just might be easier just to figure out the math, especially on some of these on this page. Just figure out the math and see when they're both the same.